So it's not uncommon to have systems of objects that are connected in some way, and you want to find the acceleration of all of the objects. So we can use a very similar method to how we solve problems with one object, with one slight change. Now, we're going to have multiple equations. So we're going to write force equations, and then we're going to solve them, and we might have to make some substitutions. So the best way to see this is to just jump into a problem. So generally, when you have multiple objects, you're going to have them connected by something, a rope or a string or a cable. So indeed, that's what we have here. And I'm going to introduce you to the idea of tension. Tension, if I take a cord, tension is going to be equal to, I'll take this one. So if I have it like this, the rope doesn't really have any tension in it, right? If I pull it, there's a force in the rope, right? The rope is being pulled. This hand feels a force pointing towards the other hand. This hand over here feels a force pointing towards that hand. Tension acts towards the other object, towards the center. So tension is kind of a new force that we're going to be dealing with. So let's go ahead and identify the relevant objects, which is going to be both of the boxes. Step 2, we want to draw our free body diagrams, right? So this time we're going to have one free body diagram for each object. Again, totally separate from each other. So our first object, which is on top, feels a force of F up and a force of gravity down, which is mg. However, it also feels tension down. So we're also going to write that as just, I'm going to write T down. We don't know what T is. Our second object feels mg down, and it feels tension up. You do not have to include F on this diagram. Tension accounts for the force that you're pulling up with. So all you're going to do is look at this. What force does it feel? Tension, gravity. This one, force, tension down, and gravity down. And that's it. Those are my free body diagrams. So 3, I'm going to choose my coordinates. Choosing my coordinates, let's say up is positive and down is negative. Step 4, I'm going to write my force equations. Now this time you're going to have 2 equations. You're going to have a number of force equations equal to the number of objects you have. So the sum of forces for block 1 in the y direction is equal to F, right? We said F is positive, minus mg minus T. You add together forces that are in the same direction. So we have minus mg minus T, and that's equal to ma. Now note that the acceleration of these blocks is going to be the same. They're connected by a rope. If one of them accelerates, so does the other one. So our other force equation for the lower block is equal to T minus mg. And that's also equal to ma. That's only because, obviously, they have the same mass, same acceleration. I could say m1, m2, and then this would be m1a and m2a. But we're assuming they have the same mass. So now what you want to do is you have 2 equations with 2 unknowns. For those of you who have seen systems of equations before, we have a system of equations. For those of you who have not, it's still very straightforward to solve. There's 2 ways of doing it. One, you can divide both sides by m for both of these. So you have a equals this divided by m, and a equals this divided by m. Set them equal to each other, and solve for tension in terms of things you do know. Take that tension, go back and plug it in here, and then you get a. The way that I prefer to do it is solve for one of the variables. I'm going to solve for tension, because then I don't have to worry about having something divided by something else. So tension, adding this to both sides, is equal to ma plus mg. Now I'm going to take this, and I'm going to plug it in to this tension. So I'm going to have F minus mg minus t, and t is this. So minus ma minus mg, and this is equal to ma. So now we can combine these mg's and add this ma to both sides. So we get F minus 2mg is equal to 2ma. From here, we want acceleration, so we can divide by 2m, and we get that a is equal to F minus 2mg divided by 2m. So that's our acceleration. However, we also want to find the tension in the string. So we're going to go back and plug this back into our equation for tension. So tension then, I'm going to write over here, tension is equal to ma, m, and this is our a. So times F minus 2mg divided by 2m plus mg. right? So, now what we can do is we can say, well, this m cancels this m. And let's get a, I want to simplify this more, so this is going to give, I'm going to give it a common denominator. So this is over 2, so I'm going to multiply by 2 divided by 2. So now I get that tension equals F minus 2mg plus 2mg divided by 2. These cancel, you get T equals F divided by 2, and you're done, and you have your tension. And that's how you're going to solve for acceleration and tension if you have a problem where you have multiple objects connected by string. You're going to solve for one thing in terms of what you know, so you'll have to make a substitution. You'll have to make a substitution, and then you're going to plug it back in and solve for the other. Go on in.
Mr. Norman,
Yeah.
did you print out the problem set?
Yeah.
Pretty sure I have questions on it, but I don't have it.
I was.
That's cool.
Let's see.